In the frozen silence of space, the James Webb Telescope has just peered back 13.8 billion years and found something that shouldn't even exist. A cosmic structure so massive, so ancient, that it threatens to shatter everything we thought. We knew about the beginning of time itself. Scientists are stunned. Some whisper it could rewrite the story of creation. Others fear it may reveal forces we've never imagined. But what exactly did Webb uncover, and could it change our place in the universe forever? 13 billion years ago, before stars lit the sky and before galaxies carved their spirals into the void, the universe was a sea of darkness. That's where the James Webb Space Telescope dares to look, into the raw, untouched past, a time when existence itself was just learning to breathe. Floating far beyond Earth's atmosphere, its golden mirrors unfold like a cosmic eye, wide and unblinking, searching across unimaginable distances. Unlike any telescope before it, Webb isn't merely watching stars. It is reaching back into time itself, capturing light so ancient it began its journey, when the universe was only a fraction of its current age. Think about that for a moment. Every photon Webb detects has traveled billions of years to arrive, carrying secrets from an era when galaxies were first assembling, when the laws of physics themselves seemed malleable. Scientists call it a time machine, but even that label feels inadequate. A time machine implies something mechanical, an invention with gears and buttons. Webb is different. It is a bridge stretching across the abyss of time, connecting our fragile present to the unimaginable violence and beauty of the cosmic dawn. And yet this telescope was never guaranteed to succeed. It survived decades of delays, cost overruns and doubts. Critics called it a gamble, too ambitious, too fragile, too expensive. But when its first images were revealed, the skepticism evaporated. In dazzling detail, Webb unveiled glittering. Galaxies piled on top of one another, spirals colliding, and newborn stars igniting in clouds of cosmic dust. These weren't just pretty pictures, they were revelations, rewriting textbooks in real time. But, for all its triumphs, nothing, absolutely nothing, prepared humanity for what Webb recently uncovered. Something so massive, so impossibly old, it threatens to upend the story of the universe itself. At first, the data looked like a mistake, an echo, a glitch, perhaps some miscalibration in Webb's instruments. But as scientists double-checked, and then triple-checked, the truth became impossible to deny. Webb had detected a structure so vast, so ancient, that it stretched the limits of human imagination. Picture not just a galaxy, not even a cluster of galaxies, but an immense filament, an arrangement of matter woven together like the bones of the universe itself. It was older than expected, older than theory allowed, forming just a blink after the Big Bang. To put it in perspective, most models suggest that galaxies and large-scale structures needed billions of years to take shape. But here was evidence of something colossal, something assembled when the universe was still in its infancy, less than a few 100 million years old. It shouldn't be there, at least not according to everything physics tells us. Imagine uncovering a fully grown oak tree in the middle of a nursery full of seedlings. That's how shocking this discovery is. Maturity where only chaos should exist. The structure Webb revealed is not small. We're talking about a cosmic wall stretching hundreds of millions of light years, a formation so large it bends our very definition of scale. Galaxies are strung along it like pearls on a necklace, connected by invisible threads of dark matter. Scientists once thought the universe was smooth and simple in its youth, yet Webb's discovery shows it was already complex, already sculpted into staggering architecture almost immediately after its birth. And if this structure existed so early, then our cosmic timeline might be broken. The Big Bang Theory, dark matter, cosmic inflation, all the pillars of modern cosmology are suddenly under question. What else might Webb find hiding in that primordial night? When the data first circulated among the astronomy community, the reactions ranged from stunned silence to open disbelief. Some scientists sat staring at their screens for hours, unable to reconcile what they were seeing. Others immediately began questioning whether Webb's instruments had been miscalibrated. After all, if the finding was real, it meant tearing. Apart decades of carefully constructed cosmological theory. 1, astrophysicists described it as a crack in the foundation of our cosmic story. Another compared the discovery to suddenly finding skyscrapers in the ruins of an ancient civilization, structures that should have taken millennia to build, but which somehow appeared overnight. The scientific journals filled with cautious statements. Words like anomalous, unprecedented, and challenging appeared again and again. Behind the cautious tone, though, was something else. Awe and a kind of fearful wonder. Skeptics, of course, pushed back. Could gravitational lensing have distorted the data? Was Webb perhaps peering through some cosmic trick of light, giving the illusion of a massive structure where none existed? The debate lit up conferences, podcasts, and social media feeds. Veteran researchers, once united under the steady framework of the Big Bang model, suddenly found themselves split into factions, those who believed the structure was genuine and those who thought it was an illusion. And yet, even the skeptics admitted one thing. The images were too clear, too persistent across different scans, to dismiss outright. Every time the telescope looked again, the structure was there, as undeniable as the galaxies themselves. Some experts whispered that we may be standing on the brink of a new era in physics, a shift as dramatic as when Copernicus dared to move Earth from the center of the universe. When experts cannot agree, speculation fills the void. And the theories that followed were anything but ordinary. The moment news of the discovery spread beyond academic circles, the theories began multiplying like stars in a galaxy. On one side stood the guardians of standard cosmology, scrambling to adjust the equations. Maybe the universe expanded faster than we thought in its earliest moments. Maybe matter clumped together more efficiently, forming vast structures sooner than predicted. Some suggested subtle tweaks to dark matter. Perhaps it interacted in ways we had never imagined, knitting the cosmos together at breakneck speed. But science rarely moves in straight lines, and where some see equations, others see mysteries. A faction of researchers began whispering about the possibility of exotic physics, hidden dimensions shaping the growth of the universe, or unknown forces that leave behind invisible fingerprints. Could it be that the cosmic web itself is not just the product of gravity and matter, but something stranger, something that blurs the line between natural formation and deliberate design? And then came the wilder voices, the ones that thrive at the edge of speculation. To them, this colossal structure wasn't just an accident of physics. It was a signal, a blueprint, a possible artifact of intelligence so ancient and vast, it would make our entire species seem microscopic. The idea sounds outrageous, yet history shows how yesterday's impossibility often becomes tomorrow's headline. After all, wasn't the very concept of other galaxies once dismissed as fantasy? Online forums exploded. Some argued this was proof that the universe is a simulation, its patterns too precise to be random. Others wondered if these structures could be the skeleton of cosmic architecture, scaffolding for realities we barely perceive. Between rigorous science and rampant speculation stretched a gulf of uncertainty, each theory raising more questions than it answered. But just when the debate seemed overwhelming, Webb revealed something else, something that turned the speculation into a far deeper mystery. At first, the colossal structure seemed like a singular anomaly, an ancient oddity that might be explained away with better models or sharper data. But when the James Webb Telescope turned its golden mirrors back toward the same region for deeper scans, the truth became even more astonishing. What astronomers saw wasn't just large, it was incomprehensible. The structure wasn't a cluster. It wasn't even a single filament. It was a sprawling network that stretched across billions of light years, a vast cosmic bridge binding galaxies into a lattice of unimaginable scale. Imagine entire galactic superclusters, each containing hundreds of billions of stars, connected like beads along a spider's web of matter. Except this wasn't delicate. It was colossal, stretching farther than some theories even allowed the universe itself to have coherently expanded at that time. The turning point came when scientists realized what this implied. According to the Big Bang model, the early universe was nearly uniform, smooth, hot plasma slowly cooling into structure. It should have taken billions of years for gravity to sculpt the first clusters and walls. Yet here was evidence that the universe, less than a few 100 million years old, had already assembled something on a scale that defied every known law. It was as if a child had been born already fully grown. The implications were staggering. If matter could organize itself this quickly, then perhaps dark matter, the invisible framework thought to shape the cosmos, isn't behaving the way we thought. Maybe it's not passive scaffolding, but an active force, guiding creation in ways we can't yet detect. Some even suggested a flaw in inflation theory itself, the idea that the universe ballooned faster than the speed of light in its first fractions of a second. If inflation worked differently or didn't happen at all, then everything we believe about the universe's birth may need rewriting. And yet, beneath the equations and heated debates, a more unsettling question emerged. If the universe can generate structures of this magnitude so early, what else might it be hiding? If complexity bloomed in its infancy, then what unimaginable architectures could exist beyond our detection today? For the first time in generations, cosmologists admitted the possibility that we may not know how the universe began, or what forces still shape it in secret. The discovery was no longer just a puzzle, it was a warning. The cosmos may be stranger, faster, and far more alive with hidden power than we ever dared to believe, ChatGPT said. If this discovery holds true, the consequences reach far beyond astronomy textbooks. It could mean our most trusted models of the universe, the Big Bang, cosmic inflation, even the role of dark matter, are incomplete or fundamentally flawed. Entire generations of scientific thought may have to be re-examined, not in small corrections, but in sweeping revisions. Students who once memorized neat timelines of cosmic history may soon face new diagrams with gaps, question marks, and mysteries left unsolved. Yet, with uncertainty comes opportunity. The James Webb Telescope has shown that the cosmos still has the power to shock us, to tear down old walls, and open entirely new corridors of possibility. This single discovery could guide future missions, more powerful telescopes, more sensitive detectors, and deeper collaborations between physicists and philosophers alike. Some scientists speculate it might even reveal hidden forces of nature, new particles or dimensions, beyond our perception. And for humanity as a whole, the implications stretch into the existential. If the universe could craft such immense complexity, almost instantly, then perhaps we've underestimated its creativity, its strangeness, and its potential. The Webb discovery is not just about the past, it's a door to the future, one we've only begun to open. As the images fade from the telescope sensors to our glowing screens, one thought lingers: the universe is not finished surprising us. For centuries, humanity has gazed upward, imagining we were close to unlocking the final pieces of the cosmic puzzle. Yet each discovery, from Galileo's first telescope to Hubble's deep field, has reminded us how small we truly are. Now, James Webb delivers the most humbling reminder of all. The universe's first chapters remain largely unread, and its story may be far stranger than we ever dared to write. There is a haunting beauty in this uncertainty. Somewhere in the silence between galaxies lies a truth we have not yet earned, a revelation that could redefine not only science, but existence itself. Some will see the discovery as proof of cosmic chaos, others as evidence of divine order. For most of us, it is simply a call to wonder, a reason to keep looking, keep questioning, keep daring to know. The massive structure Webb uncovered may not offer final answers, but perhaps that is the point. The greatest mysteries are not solved in a single lifetime. They are passed forward like torches, lighting the way for those who come after. And in that endless search, humanity finds its true place among the stars.